the answers to the quiz that we've just done. So for these first 5 multiple choice questions, most of them you could have put straight into your calculator and got the answer, as long as you put them into the calculator properly. So the first one was something that you need to use factor on your calculator. So factor 27x cubed minus 8. I usually put the comma x, and when you do that, you get the answer of D. For the second one, the coefficients of each term in the polynomial. Okay, so we're just looking at the order here. So we've got a 1, we've got a -2, we've got a -1, we've got a 4, and we've got a half. So your answer there, if you match it up, is B. The third one here, a possible equation for this graph. So what do we know about this graph? It's a positive cubic. You can see that one of my x-intercepts is at -1, the other one is at +3, which would mean that as a factor, this one would be x plus 1, and as a factor, that would be x minus 3. This one here is touching, okay, which means it's a squared factor. So when you put all of that information together, C must be your answer. All right, so the next one here, we've got the graph of y equal to x cubed minus x squared minus 10x minus 8. Again, if you put that into your calculator, you will be able to see. Now, there's a few ways you could do this. You could just basically find your x-intercepts when you put it into the graphing system, or you could factorise this if you wanted to and find out what the x-intercepts actually are. So if I factorised it, which is what I did, I got x minus 4, x plus 1, x plus 2, or even solve probably would have been better there. So you get x is equal to 4, -1 and -2. You can see that it is a positive cubic, so straight away you know that you could get rid of which one? E. The others are still quite feasible, but when you now match up your x-intercepts, you can, and your y-intercept here is -8, you can therefore see that the answer should be C. For this last one here, a negative cubic goes through the points -3, 0, -1, 0, 5, 0, and 0, 2. Okay, look, you could put it into your calculator, but it might not give you the form that you want. So a better way of being able to do this would be to use the information that you've got. So what you know is that y is equal to, I'm going to use all of the x-intercepts here, which are the first 3. Okay, so I've got y is equal to a outside of x plus 3, x plus 1, and x minus 5. All right, and so now I'm going to use my other point, which was 0, 2, okay, to be able to find my a value. So my a value becomes 2 is equal to a outside of, now remember x is 0, so it's 3, 1, and minus 5. 2 is equal to a times minus 15. 2 divided by minus 15 is a. So you can see, therefore, that my equation is -2 on 15, x plus 3, x plus 1, x minus 5. And of course that gives me the answer of E. All right, the next one. So these are short answer questions that we're not using our calculator for, they're technology free. So in this question we're asked to sketch the graph of f of x equal to 2 outside of x plus 1 cubed plus 2. Ensure that all the axes, intercepts and turning points or points of inflection are clearly labelled. Well, what do we start off with? As usual, we will start off with the trend of the graph, and we know that this is a positive cubic, so it's going to look like that. And because it's in point of inflection form, that's the format of our graph. Our point of inflection here is read off from the equation, and it is -1 and 2. All right, so we've got some information at this point. The next bit of information we need to get is the x-intercept and the y-intercept. X-intercept, we let y equal to 0, so you get 0 is equal to 2 outside of x plus 1 cubed plus 2. First thing to go across is the 2, so minus 2 is equal to 2 outside of x plus 1 cubed. Next thing to go across is the 2, and we are dividing, so it becomes minus 1 is equal to x plus 1 cubed. Take the cube root of minus 1 equals x plus 1, and then bring the 1 across. Now the cube root of negative 1, a lot of people made a mistake here. The cube root of negative 1 is negative 1. And then bring the 1 across, becomes another negative 1. So altogether you've got x is equal to negative 2. My y-intercept, where I let x equal to 0, okay, I'm going to get y is equal to 2 outside of 0 plus 1 all cubed plus 2, okay. 1 cubed is 1, so 2 times 1 plus 2 is equal to 4. So my coordinates there, if you like, are minus 2, 0, and this one is 0 and 4. So let's set about graphing this now. The first point that I would probably plot here is my point of inflection. So negative 1 and 2 would be there. Okay, now I know that it's sort of going to go through there like that. The next point that I'm going to plot is my y-intercept, 0, 4, and my x-intercept is at negative 2, 0. So trying to get all of that lined up would look like that. Again, that's negative 1 and 2. Don't forget to label your axes. And there is my graph. Alright, the next one says the remainder when x cubed plus ax squared plus bx plus 1 is divided by x minus 5 and x plus 1 is negative 14 and minus 2 respectively. Calculate the values of a and b. This question was done quite poorly, so very important that you have a look at this one. Alright, so what do we know from this question? So we know that when this polynomial is divided by x minus 5, the remainder is minus 14. So p of 5, remember it's always the opposite to what's in the bracket, is equal to minus 14. And we also know that p of minus 1, so the other factor there, which was x plus 1, so that means that x is negative 1 and the remainder was 2. Sorry, negative 2, so negative 2. And of course my polynomial is the x cubed plus ax squared plus bx plus 1. So what are we doing here? Let's use the first point there, which was p of 5 equal to minus 14. Now if I write that as a coordinate, it is the same thing as when x is 5, y is minus 14. And I'm going to substitute that into my equation there, my p of x equation. So I get minus 14 is equal to 5 cubed plus a times 5 squared plus b times 5 plus 1. Alright, let's tidy that up. So that's minus 14 equals 125 plus 25a plus 5b plus 1. I'm bringing all of my numbers without letters over to one side, and I get negative 140 is equal to 25a plus 5b. And I'm just going to tidy it all up by dividing by 5. So I get negative 28 is equal to 5a plus b. That is my first equation. My next equation, okay, I'm going to use the other point that I've got there, which was p of negative 1 equal to negative 2. And of course, as a coordinate, that is -1, -2. So let's put that into our equation as well. And you get -2 is equal to -1 cubed plus a outside of -1 squared plus b outside of -1 plus 1. All right, tidying it all up, and you get -2 is equal to -1 minus a, I beg your pardon, that's plus a, minus b plus 1. Get all your numbers over one side. No, that cancels with that anyway, and you're left with -2 is equal to a minus b, and that is your second equation. What do I now do with those equations? Okay, so you can see my two equations are 5a plus b is equal to -28, okay, and I've got my other one, a minus b is equal to -2. Two unknowns, two equations, so that suggests we need simultaneous equations. So let's do that. Now the best thing to do here would be to add my two equations together, because what I want to do is get rid of one of those unknowns. So if I add them together, I get 5a plus a is 6a, plus b minus b cancels, minus 28 plus a -2 is minus 30. Right, and so a is equal to -5. And the last step here is to find your b value. So substitute a equal to -5 into one of those equations. Probably 2 is easier, but it doesn't really matter. And so you get a, which is -5, take away b is equal to -2. So minus b, bring the 5 across, and you get 3, -2 plus 5, and then divide by the negative. So b is equal to -3. Now, have I answered that question? Calculate the values of a and b. Yep. So therefore, a is equal to -5 when b is equal to -3. This question was done poorly in that people didn't look at what they were supposed to use, and that was the remainder theorem. A lot of people used long division. And the other issue here was that it was a show that. So you needed to have some sort of statement at the beginning to tell people what you were going to show. So we know that if we substitute an x value into a polynomial and the answer is 0, that therefore that x value becomes your factor. So your statement here should be something like prove f of 2, because we know the function is 3x cubed plus 2x squared minus 19x plus 6. So prove f of 2 is equal to 0, and therefore x minus 2 is a factor. So that's a statement of what I'm going to do. So how do I do that? Well, then I'm looking at the left-hand side there of the equation. So it's going to be f of 2 is equal to 3 times 2 cubed plus 2 times 2 squared minus 19 times 2 plus 6. And of course, when you work all of that out, you end up with 0, which is equal to the right-hand side there. And so therefore, x minus 2 is a factor. So it's just being a little bit particular, especially when it's a show that question, that you make sure that you put a statement of what you're actually going to show. And hence give all the linear factors for that particular function. So because we know now that x minus 2 is a factor, we can use that in order to do long division. So it's going to go into 3x cubed plus 2x squared minus 19x plus 6. All right, so x goes into 3x cubed, 3x squared. Most people did this quite well, actually. So you get 3x cubed minus 6x squared, subtract, and 2 minus minus is plus, so you get 8x squared, bring down the 19. So 8x squared minus 19x. How many times does x go into 8x squared? The answer is plus 8x. So it's 8x squared minus 16x, subtract, minus 19 plus 16 is minus 3, minus 3x. Bring down the 6. And of course we know because it's a factor that we should end up with 0. So do we? Because if we don't, something is wrong. X goes into minus 3x minus 3 times. Minus 3x minus 6 is 0. Okay, so where does that leave us? It leaves us with the factors being x minus 2 and 3x squared plus 8x minus 3. Now, they are not linear. Only one of them is linear. 3x squared plus 8x minus 3 is not. So how do I now go about getting linear factors? I need to factorise my quadratic. A couple of ways you could do that. Cross-bridge or decomposition. A lot of people did not do this very well. Okay, they stuffed up their numbers. So my factors are minus 1 and 3. So when we use the cross-bridge method, remember we go across. So it's x times minus 1 is minus x. 3x times 3 is 9x, and that gives me my positive 8x. So my factors therefore are x minus 2. Now I read them off across though. So it's 3x minus 1 and x plus 3. So it asked us to give all linear factors. They are factors. Do not now go on and finish that and solve it like some people did. That is your final answer for that bit there. The next part is asking us to sketch that graph. Now we've got all of the information already. Because we've already factorised it, we know quite a few things about this graph. Let's look at it. First of all, we know that the graph is a positive cubic. Now it's not in turning point form and it's a positive cubic, so it needs to look like that. Also, because remember, f of x was equal to 3x cubed plus 2x squared minus 19x plus 6. So we know straight away that our y-intercept, just reading it straight from the equation, is when x is 0, y is 6. Our x-intercepts we've also got from the previous part of the question, because we found the factors to be x minus 2, 3x minus 1 and x plus 3. It meant our factors were 2, 1/3 and minus 3. So x-intercepts 2, 0, 1/3, 0 and minus 3, 0. So sketching our graph from there, I've set up my axes. All right, now remember this question says don't worry about the turning points at this point because we don't know how to find them. So let's just plot what we do know. And we know that we've got the point -3, 0. Oops, it's over there. So -3, 0 is 1 point. We've got when x is 2 and 0, which would be there. And we've got the point 1/3 and 0, which would be around about there. Okay. The smaller you scale, the more accurate your graph is actually going to be. And the other point that we know is the y-intercept, which is 0 and 6. 1, 2, 3, 4, 5, 6. So that's that point there. Okay, and my graph needs to go through that and it needs to follow that trend. So you should end up with a nice free-flowing graph. Again, we don't know how high up we need to go for our turning points or how low down, but everything else should be to scale and look nice and smooth. Question 5, not done so well either. So we're told that the graph that we're wanting to find has the rule f of x equal to a outside of x plus b cubed plus 2. And we've got a diagram of the graph. We knew the graph was going to be in point of inflection form because of the way the equation is written and just by looking at the graph. And straight away you can read off that the point of inflection there is equal to 1 and 2. The other bit of information you know about this graph is that you have the point that it goes through, which is 3 and 6. So let's put the point of inflection in first. We know the format, f of x is equal to a outside of x plus b cubed plus 2. Now, if I put the point of inflection in there, f of x is equal to a outside of x minus 1, because remember it's always the opposite, and my x value is positive 1, so x minus 1 all cubed plus 2. So straight away we know that our b value is negative 1. Now I'm going to find my a value and I'm going to use the other point. Don't use the same point again. So I'm going to substitute that in, and I've got when x is 3, y is 6. So I get 6 is equal to a outside of 3 minus 1 all cubed plus 2. Alright, so 6 is equal to 3 minus 1 is 2, 2 cubed is 8, so it's 8a plus 2. Bring the 2 across, you get 4, and then divide by 8, 4 on 8, which is equal to a half. Make sure you state, the question said find the values of a and b. Some people just wrote the equation, and that's not telling me what a and b are. So a is equal to a half when b is equal to minus 1. Alright, so looking at the last one here, we are asked to find x. So we want the solutions of x. Fortunately, this is already in factor form for us, which is nice. So we can see straight away that our x-intercepts, and I'll do this in a different colour, our x-intercepts are negative 3, negative 4, negative 7. Now it doesn't ask us to draw the graph, but the graph will help us. So my graph is a positive trend. I know that it has x-intercepts at negative 7, negative 4, negative 3. Alright, so that's basically what my graph looks like. Again, it didn't ask us to draw it, but we're using that to help us find our solutions. So now let's have a look at what our solutions are. We want the values, we want the graph to be less than or equal to 0. So that means on and below x-axis. So where is that on our graph? It's that bit there, including that point. It's that bit there to there. So it's the purple bit that I want. So how do I write that? Well, in interval notation, it goes from negative infinity. Now, infinity always has a round bracket up to negative 7. We are including negative 7, so it's a square bracket in union with. And again, I'm going from the smaller one, negative 4, up to the bigger one, which is negative 3, and including them, so square bracket. In set notation, it would look something like this. So x such that x is less than or equal to minus 7. In union with, now it's between two values, so x such that, now x is greater than or equal to minus 4, less than or equal to minus 3. Both of those answers would be fine because it didn't ask you to write your answer in a particular format.